Hello, everyone. This is John Rogers. I work at SwissRe based in Zurich, Switzerland. And one of my roles or functions at SwissRe is configuration management on Windows. And obviously the tool that we chose for this is Puppet. And so I wanted to talk to you today about some of the ways that we use Puppet to help us configure and automate things on Windows. So I wanted to start with a little bit of background with how we have our Puppet environment set up, how many machines that we manage, and then go into some more detail about different modules that we use and different ways we use Puppet to help us perform automation tasks. So in our environment, we have two separate universes set up. So we have our engineering universe where we do all of our code development and testing. And then we have a production universe, which is basically where all of our machines at SwissRe are connected. So we have a code deployment program where once we've done our development, we've done our testing, then the code is pushed from our engineering universe into the production universe. So we are currently on Puppet Agent 6.18 on our Windows boxes. So we do a pretty good job of staying up to date on the Windows side. And we also share the environment with our Unix colleagues. So we run about 6,000 servers on our Puppet production universe. And it's about 3,500 Windows machines and 2,500 Linux machines, give or take a few. And so I stole some of my slides from the earlier Puppet camp. So some of these numbers are slightly different, but they roughly estimate what we currently have today. So we have about 3,500 Windows nodes. Quite recently, there's been a lot more migrations from Windows 2012 to 2016, so that number's probably slightly changed. And I think the more interesting number here is the total number of resources or the resources per node. So we've been able to, from a Windows 2016 perspective, completely manage the machine with Puppet. So we're averaging probably around 1,600 resources per machine on the Windows 2016 machines. So this number will continue to grow as we add more functionality and as we migrate machines from 2012 to 2016. So just a few little different things that we do at SwissRe. So we do allow some of our customers to write their own Puppet code. So we integrate their Git repositories into our Puppet master. So we have scripts that I guess check every few minutes to see if they've created some tags and they want to release code. So they can actually manage their own Hiera data, they can manage their own Puppet manifests. And we have a couple customers who do this on a regular basis. We've also kind of separated out a lot of the Puppet Forge modules into their own repos at SwissRe to allow people to more easily browse to see what's available to use, since our current Puppet repository isn't really browsable by anyone else. So for this, we use R10K and some other custom stuff at SwissRe. And then in our private cloud provider, I think one of the nice things that we have is the customer either through an API or through the GUI can go to the public cloud or the private cloud. They can order a machine, they can select the Puppet role that they would like to have. And with basically clicking 2 or 3 buttons, then the machine is provisioned, it's configured exactly the way they need it. And depending on patching, 20 minutes later or 2 hours later, then they have a fully configured machine with making basically one API call. So I gave a presentation earlier this year, so I stole some more of those slides. I wanted to kind of quickly go over some of the things we had presented last time, just as a refresher, and maybe some updates, and then I'll get into some of the newer things that we're working on. So one of the things that allows us to manage so many resources on 2016, and actually to fully manage Windows 2016 with Puppet, is the GPO module that we created. Unfortunately, we haven't been able to publish that to GitHub or the Forge. It's not really in a shareable mode. I had tried to maybe see if we could get that for people to use, and unfortunately, yeah, it's not really in a state for sharing. So maybe in the future, we'll have something else that we can put out. But basically what we've been able to do is to take all of the ADMX files from Microsoft. So basically all of the GPO files, we can parse those. Then we parse the CIS standards that come from CIS. And we end up producing basically a set of manifests along with the type and provider where we can pretty much just manage every setting that you can manage from the GPO. So we pretty much just start with the CIS standard. So as we roll out a box at the very beginning, we're roughly 99% CIS compliant for any new machine that's built, minus some of our kind of global configuration settings that don't quite match the CIS standard. So this really allows us to completely manage the Windows machines with Puppet without having to rely on multiple configuration management tools. So we had issues with GPOs kind of conflicting with what we were trying to do in Puppet. So we made the choice, let's just see if we can do everything with Puppet. So that is that. This is just some screenshot examples of what some of the files look like and the different manifests that we create from the CIS standards, and kind of how we parameterize all of the manifests. So the nice thing about this too is every single setting from the CIS standard as it comes through here is also parameterized in the classes. So that means if any machine or any group of machines or any environments need different settings, then we can just easily go to Hiera. We can type in a value and poof, those machines now happen to have a new value. So basically like going into the GPO and clicking a new value. One of the reasons we actually chose to go this way as well is instead of just making registry updates, which we had kind of started to do at the beginning, by actually parsing and creating the registry.pol file, it actually shows up inside the local GPO editor on the machine. And this is quite nice because then system administrators can actually just open up the tools that they're used to looking at, and they can actually see all of the settings and how they're configured. Another thing that we had to, well, we didn't have to. Another thing that we created was a module to manage the local security policies. So inside the local security policy or inside the GPO, you have access to the system access area, the user right assignments. There's an auditing section. And at first we were using some of the modules that we found on Forge. And then we realized there was some more functionality that we needed. And for us, this was an opportunity to kind of learn things about types and providers. It was our kind of first experience working with Camp to Camp and seeing how you can take kind of a Ruby master, have him come help you on Windows, which he's never logged on to before. And this combination of having this subject matter expert with a Puppet Ruby expert, it's quite amazing at some of the things that you can accomplish. And so we kind of use this as a learning tool, and we used it to provide more functionality that didn't currently exist in the modules that we were looking at. So this is currently on the Forge. We're in the process of getting all the documentation and the spec tests written for it. It's pretty much usable at this point, but without the documentation, it might be difficult to understand. So this is kind of one other section from the GPO that we needed in order to fully manage Windows with Puppet. And I'll just skip through this. One of the other things that we really needed to do was to have a software delivery system in Windows. So in the past, we weren't using Active Directory or GPOs to deliver software, but we were using SCCM. So we're using the Microsoft System Center for that. And it's not very, I don't want to say not cloud friendly, but it's not as responsive as you would like in an on-demand type of tool. So we decided to go with Chocolatey, and then we use ProGit to store our software feeds. And so the really nice thing about this is we can actually configure machines to connect to multiple feeds based on maybe what application's running on the box, whether the machine is a dev machine or a production machine or a non-prod machine. And then we have kind of a whole Azure DevOps release process around this, where we can release our packages into the different feeds, have them promoted, and then the software is available for people to install or to automate with Puppet. And then one of the final pieces of this was we released virtual machines on premise. So on our ESX infrastructure, we release it into the private cloud. And I guess shortly we might be also releasing things into the public cloud. So we needed a way to build images and maintain images. And unfortunately, if you do this manually, it's quite a time-intensive task. So we use Packer IO for this. And we actually have a Packer IO role in Puppet. So as the template is actually being built through Packer IO, it connects to the Puppet master. I would say it runs roughly 90% of our standard configuration settings in Puppet. And so that when we ship the template off to our internal ESX infrastructure or to the private cloud, then most of the settings have already been applied to the machine. So it makes the initial configuration of the machine much, much quicker. Okay, so now to get into some of the newer things that we've been working on with Puppet. And these aren't really listed in any particular order. They just happen to be the way I thought about them and put them on the screen. And so I thought what I would show is there's a lot more you can do with Windows than just kind of say, I'm putting some registry settings on here, or I'm setting some CIS standards. So with Windows 2016, with Windows 2012, we really tried to do all of our management with Puppet, whether this is mitigating some type of Spectre meltdown thing, finding ways to easily deploy certificates on machines, or anything like that. So I'll walk through this. So one of our SQL team came to us one time and said, hey, I would really like to use this just enough administration so that our operations guys could run scripts, could run PowerShell commandlets, but they didn't need to log into the machine and be administrator on the box to do things. So we kind of started working with that, and now I think we have something that more or less works, though we want to make some improvements to it. So currently I think it's published on GitHub. I don't think I've updated it to the current release yet, and we'll probably just release this through Camp to Camp as well as one of our consulting partners. And so what it basically does now is just by using Hiera, the customer can kind of go into Hiera. They can define their role capability and the role definition files just in Hiera, saying, okay, I would like to be able to run this commandlet with these parameters, and these are the values you're allowed to pass through the parameter. So it's kind of like, I mean, I hate to make the comparison, but it's like a sudo for Windows using PowerShell. And so we have a template created for this. We have a custom definition for this. So you can basically just download it, fill out some Hiera data, and then you can start using this just enough administration with remote PowerShell. So that's been pretty fun to work on. One of the other issues that we had at work is a lot of our certificate stuff for the PKI infrastructure was set up initially to support mostly the desktops and the laptops and the users. So from a server perspective, it was never kind of a priority that every server have a server certificate. And so by not using GPOs and not kind of working in this auto-enrollment paradigm, we need a way to have certificates stored on the machines. And so currently what we have right now is just a fact that reports on the certificates currently installed and when they expire and things like that. And what's currently being developed is a way for the machine to kind of talk to the API that we have in front of our PKI infrastructure, so that using the trusted cert from the Puppet master, then the agent can order a certificate for its fully qualified domain name. So what we haven't really been able to solve yet is how to automate the request and installation of tickets for services, because we don't quite capture that information in our configuration management or service management infrastructure. So I kind of have no way to tell if this person's really allowed to request a certificate for this domain name. So all we're doing now is then to be able to roll out so every machine can automatically get a fully qualified certificate, and then it will take care of auto renewing that when it's getting close to expiring. I guess this started last year. I wasn't too involved in this, but I guess when things hit the news and the managers start really complaining and freaking out about every machine's going to be owned and taken over in the next 2 weeks, please run around and patch the machines and do this and do that. And so what we decided to do was just do it with Puppet. So when the whole Spectre meltdown thing came out, and then plus the subsequent mitigations, we pretty much just did that with Puppet. So I think Microsoft had kind of published a workflow of if your machine looks like this, and if your machine looks like this, and it also does this, then this is the type of mitigation that you need to do. Either it was installing patches, it was setting registry keys to turn things on or off. And so what we pretty much did was we built a module, and our paradigm with Windows and Puppet is we pretty much try to control everything with Hiera. So we try very hard not to hard code values into the Puppet manifest. And I can show you our Hiera stuff here in a little bit later. And so this really helps us to drive how we can deploy things across the Windows estate. So whether it's by the type of application running on the box, whether it's for one domain or a different domain, whether it's for the environment dev or the environment production. So we have a lot of fine-grained control of how we can roll out patches or how we can roll out fixes or different configurations. So with this, like I said, with about 3,500 Windows servers, I think we basically had one guy that worked on this part-time. He maintains it whenever there's new things coming. And then we can roll this out we can roll it out to dev machines, we can test it, roll it out to production. And with this, we were able to say, okay, for maybe Exchange servers and SQL servers, let's not roll out these mitigations because of the CPU speed impact. So it was quite flexible and made it quite easy to control how we could mitigate this. One of the projects that we took on this year also, which was pretty neat to see, is on the older versions of Windows, we're using McAfee for the sole purpose because it was already rolled out in the infrastructure, because that's what we were using on laptops and desktops. So the workplace people decided they want to go a different direction. They would like to use a different type of antivirus malware detection. So don't scan this file, don't scan this path, don't scan anything that's open by this process. And we converted those all into Windows Defender exceptions and created host YAML files in Hiera. So the first step was to then basically parse the Puppet DB to pull out these facts for all the machines, and then to create YAML files for all the hosts. And then the second piece was, well, obviously we had to write the code and the chocolatey package to do the installation and the uninstall of McAfee and things like this. But basically it's set up so that per machine, per dev environment, per OS, per application, basically anything, we can just set this engine value in Hiera. And then the next time our Puppet code or Puppet agent runs, then it will just take care of migrating the machine over from running McAfee to running this System Center endpoint protection. So it just nicely migrates everyone away from McAfee and points to our basis infrastructure. And so we don't need to log into machines. We don't need to do this 20 machines per night because there's only one person working and it takes 6 months to do the rollout. So Puppet really, really helps us to do these types of phased rollouts, or these types of this work where we're migrating from one thing to another, where in the traditional way you would need to go jump on every single machine and do something. So it's been pretty helpful to see that. And just what it looks like in Hiera for something. One of the other things that we do So one of our philosophies is we don't have a lot of people. And so whenever we do things in Puppet, we need to really make sure we can do things hands-free. It's not enough to do a task one time, but we want to be able to continually do it in an automated fashion. And so with 3,500 Windows machines, we constantly upgrade our Puppet agents. So every time a new version comes out, then pretty much we start in our engineering universe and we go set the Hiera value to be, okay, I want to now use 6.19. And on the next Puppet run, all the machines that are in this universe will just upgrade themselves to the next version of the Puppet agent. And then the same in production. Once we've kind of tested it, then we just do a change in Hiera for dev, for non-prod and prod. And then over the course of, I don't know, usually 1 to 3 weeks, then we roll out the new Puppet agent to all the machines at SwissRe. So we have a chocolatey package built for that handles this upgrade logic to handle making sure there's no service dependencies, that it's okay to shut some services down and things like that. And then actually the way it works is we create a scheduled task that launches the Choco upgrade. And then inside the chocolatey package, there's logic that states, okay, wait for this current Puppet run to finish. So once the lock file on the Puppet agent's done, then it starts the upgrade process. So this is helpful because we don't need to spend any operational time upgrading the agents. So we can stay pretty current with this. We also manage all of our Windows Defender configurations on the machines with Puppet. So the Windows update agent, how often it checks in, what patch group it points to, what VASIS server it points to, and then all of the Windows Defender exceptions are managed via Puppet. And the nice thing about this is, the way we have it set up is inside the manifest, we just do a Hiera lookup with the merge option. So that means we can set all of our default Windows Defender exceptions in the default YAML file. Then per application, if they have special exceptions that they need, so for SQL machines or SharePoint machines or things like that, then we can actually define a role for them. Then we can attach all the vendor recommended Defender exceptions to the role. And then as we're compiling the lists, Hiera just looks up everything, merges it, and then sticks it in. So this works out really quite nicely. Something we've been thinking of moving to, but we haven't got there yet. So we currently use a different tool for Windows patching. However, we do have our VASIS infrastructure set up to patch machines if we ever wanted to go that way. So it's not really a technical thing, it's more of a priority governance type of thing. So we have a few modules and manifest files written so that we can kind of auto-maintain the VASIS infrastructure. So what patching groups are available, how the patching groups work, what patches and what products get auto-approved for the different patch groups. And the way this kind of works is we use Puppet. So I can go define all of my patch groups, my update rules, and everything like that in Puppet. And it builds a JSON file, and then the PowerShell script that runs on the VASIS machines just parses the JSON file, and it builds all the patch groups, it auto-approves all the patches. So it makes it really easy to maintain, because in VASIS, there's really no way to do this via the GUI. So most people already use PowerShell scripts to do the auto-approvals of things. So currently, we just use this really to do Windows Defender updates. But it's set up now that if we wanted to switch people over and start doing patching with VASIS, we could. So the part of the Packer IO build connects here, and it does the patching through VASIS. I don't know how many people do RSPEC. It's something we've been doing over the last couple of years, but really not super involved. But starting this year, we've been really pushing to make sure that everything we do also involves RSPEC. So we've been having to go back through and write RSPEC files for all of our current code. So we have about 1,500 Puppet manifests that are actively being used and some custom facts. So we're in the process of kind of going back and running tests for all of these. in the end, this is really cool. So a lot of this stuff, we're split between Unix and Windows, but even the Windows side, we've been using the PDK installed on the Ubuntu box, and then struggling with some of this, how do you run my tests for Windows things on a Unix box? So some of my Ruby library files are missing because it's a Ubuntu box and not a Windows box. And how do I mock this? So what we'll do, we're getting some help from Camp to Camp soon. And what we'll do is once we got all these questions answered and everything, then on GitHub, we'll post all of our examples and all the things that we're testing and how we were able to mock things and get it to run on the Ubuntu box. So this has been really challenging and it's been a lot of fun. And then just the very last thing I wanted to touch on is, I don't know how extensively other people use Hiera, but when we first started using Puppet on Windows, our philosophy was really, I want to write the manifest one time, and I want to control how this applies my configuration based on Hiera. So we kind of specifically started configuring all of our roles and our profiles and our manifest to really utilize Hiera. And so we basically have connections to a password vault. Then we have a CMDB where we can put entries on individual machines. And then we have kind of our lookup table. So what we had found was there were many different ways where my configuration could change on a machine. And so we wanted to reflect that in Hiera so that we didn't have to write separate manifest files based on certain criteria. So this is kind of our current type of working split in Hiera of how we can configure different machines. So obviously the first one is based on role. And so for us, a role is it's application specific. So the way we have it set up, so we have many thousands of applications at SwissRe. And so the way it's kind of set up is your role is based on your application. So I could have a web server for this application or maybe a web server for this application. So this first piece is really, I can break it up by the role, and not only role, but per environment. So a role that runs across dev, non-prod, and prod, I can actually apply different settings to those machines based on the YAML files. And then one of the next things we needed was really based on the application running on the box. So I want to treat all of my Exchange servers the same. I want to treat all of my SQL servers the same, all of my SharePoint servers the same. Same meaning maybe I want to apply Defender exceptions, or maybe I'm not allowed to mitigate this meltdown risk because of CPU or performance impacts. So this helps us to actually be able to put separate configurations on based on the application that's running on the box and without having to change the manifest files. And then we have some of kind of the standard, right? It's a dev box, a non-prod box. Then we run multiple domains at SwissRe. So if I'm managing my local administrators group, I need a way to distinguish if it's running in domain X. I need to put different entries in my local administrators group than if it's running in domain Y. So we can do that easily with Hiera without changing the code. And then this latest thing that we did is we were struggling with how do we push things out with Puppet, because we pretty much say I push to dev, then I push to non-prod, and I push to prod. And it wasn't much more granular than that. And what we decided was, well, maybe it's not great to push to 1,800 machines in one day. Not necessarily because we didn't trust what we were doing in Puppet, but it turns out maybe some of the backend systems that we had, maybe they weren't ready for that type of configuration change. So for instance, recently moving to a new monitoring platform, they were scared that if we turned the monitoring on for 1,800 systems in one day, it would overwhelm their monitoring infrastructure and it would just collapse. So now we kind of have deployment groups where we can actually roll out Puppet changes in production, but in a phased approach in production. So that's been pretty useful too. And that pretty much brings me to the end of my presentation, and just wanted to get a shout out to the consultants that help us at SwissRe do our Puppet stuff. Thank you very much.